going to assume energy generation is present. So E dot is Q dot times the volume delta V, which is going to be the surface area all through big question is, should I take the surface area of the outer ring or the surface area of the inner ring when I'm calculating energy generation, or does it matter? Or should I take the surface area in between the inner and the outer ring, which is the middle surface? And if I have so many possibilities, you know that the answer is it's not going to matter. Because what we are going to say is that this delta R, in the limit of delta R tending to 0, the small differential quantities, if they are multiplied by one another, I get a delta R square. I'm going to discard all those higher order terms. Okay, so in this situation, it does not matter which area I am taking for the volumetric energy generation. So I'm just going to call this as an area 2 pi R times L, where R could be an average radius. R could either be R, or R could be R plus delta R by 2, that's another possibility, or R could be R plus delta R. And the reason why it does not make a difference is because if I look at the differential volume delta V is A times the thickness. And if I do the multiplication, 2 pi, if I take, let's say, the middle surface in between the top and the bottom elements, I get a factor of delta R times delta R, which is delta R square, so those terms will be discarded. So this is approximately 2 pi R times L times delta R. This is delta. Or delta V is A times delta R. Okay? Energy generation is there, unsteady effects are also there, so E dot stored is not 0, this is E dot G. E dot stored is not 0. I write the basic energy balance, couple more minutes and then I'll let it go. E dot N minus E dot out. I'm assuming positive energy generation, not necessarily needs to be the case, but you know, why not? E dot stored. E dot in and E dot out. Look at the two-dimensional view of that ring. I can either assume one direction or the other, but it makes more sense to assume that the conductive heat flux is going to start, if it is a solid body, it's going to start from the center of that cylindrical body and move out. Can somebody tell me why? So, this is a solid piece of steel, okay? And I'm going to say that the conductive heat flux direction is going to start from the center and radiate outwards. Could there be a physical reason for it?
Heating element?
Say that again?
A heating element?
No, heat, I mean, you can, I can, let's say there's a nuclear reaction taking place inside. Energy generation and all that. Yeah? Exothermic, endothermic. Let's say energy generation is negative. Makes no difference. We are saying something really, really critical about a boundary condition at the center of the solid cylindrical body. And I am saying that heat can travel in only one direction, either in or out. Okay, so in this case I am saying that heat is traveling radially outwards, which implies that no matter what you do, the conductive heat flux at the center point should be 0. Okay, that has to be the case. This is the symmetry boundary condition. I cannot have lines of heat crisscrossing the center. I can't have one line of heat coming through and then going this way. That's ridiculous, that's not happening. Okay? I can only have it going out this way, going out this way, going out this way, and out this way, and out that way, for a solid body. Alright, so I'm going to stop here. We're going to come back, complete this derivation really quickly, and start solving problems on these kinds of problems.